Okay, here's the last example we're going to do from 4.1. This is example number 5C. We're going to add a little bit of trig in there, so it's going to get a little more complicated. Hopefully you know your trig identities. Hopefully you know your unit circle. Some of you lucked out that I can't give you a pop unit circle quiz. Darn it. But make sure that you practice your unit circle values and being able to identify your trig identities, okay? So in example number 5C, it says to find the extrema, the absolute maximum and minimum of our function on the interval from 0 to 2 pi. So I know that if I want to find absolute maxes and mins, I need to figure out first what my critical numbers are. I then need to take those critical numbers and plug them into my original so I can see where I'm at. But I know my endpoints could be higher or lower, so I want to take those endpoints and plug them into the original and then compare all of those values. Okay, let's do it with trig this time. So my first step is to find my critical numbers, where my derivative equals 0 or where it doesn't exist. So I'd like you to pause the video. I'd like you to practice your derivatives, and I'd like you to find me the derivative of this function. I ended up getting 2 cosine x plus 2 sine of 2x. There's a little bit of chain rule on that second piece. Did you get the same derivative as me? Okay. And so now that I have that as my derivative, I'm going to take that derivative and I'm going to find my critical numbers. I'm going to set it equal to 0 or does not exist. In this case, there is no denominator, so I'm just going to set it equal to 0. At this point, we now have a trig equation that we need to solve. So this brings us back to our trig or our pre-calc class where we have to be able to solve trig equations. I noticed on this trig equation I have cosine and sines, and I have a cosine of x, but then I have a sine of a 2x. And so because those aren't the same, number one, trig functions, and they're not the same angle, I'm a little bit stuck. And so hopefully you have a little bit of a red flag going off in your mind, and you notice that I have a sine of 2x, and you should be able to recognize that that's a double angle, and you should be able to take your double angle formulas and convert that sine of 2x using those double angle identities. Take your yellow sheet out if you have it. Hopefully you are practicing your trig identities in case they're on the test, but you should be able to take that sine of 2x and you should be able to turn it into a 2 sine x cosine x. So now our problem looks like this. Okay, I'm going to simplify it a little bit. I'm going to turn that into a 4 sine x cosine x in that second term because 2 times 2 is 4. And then I notice that in each of these terms, I can GCF out a 2 and a cosine x. So that's what I'm going to do. I'm going to GCF out a 2 and a cosine x. That leaves me with a 1 plus 2 sine x. I can now, since everything is factored as much as possible, I can set each piece equal to 0. So I'm going to set this piece equal to 0, and I'm going to set this piece equal to 0. I'm then going to solve both of those equations. In that left one, I end up getting a cosine of x equals 0. In my right equation, I end up getting sine of x equals -1/2. You should now be able to use your inverse trig and your unit circle and figure out where on the unit circle does cosine equal 0 and where on your unit circle does sine equal -1/2. So this is where you need to know your unit circle values. I ended up getting that arc cosine of 0 is pi over 2 and 3 pi over 2. On the unit circle at pi over 2, cosine is 0. On the unit circle at 3 pi over 2, cosine is also 0. So I have two critical numbers there at pi over 2 and 3 pi over 2. So where on a unit circle does sine equal -1/2? Well, I got 7 pi over 6 and 11 pi over 6. So I ended up getting actually 4 different critical numbers here where my derivative equals 0. I have 4 possible places where I have those smooth curves. My possible extrema. But who could be higher or lower than those smooth curves, those relative extrema? Well, my endpoints, right? And so my endpoints are 0 and 2 pi. So then I have to make sure that I plug in all my critical numbers and my endpoints into my original function so that we can figure out who the highest value is and who the lowest value is. we should be then evaluating 1, 2, 3, 4, 5, 6 different functions, or excuse me, different values into our function, into our original function here. So now I need you to pause the video. I need you to take a few minutes. I need you to plug in 0. I need you to plug in pi over 2. I need you to plug in 3 pi over 2, 7 pi over 6, 11 pi over 6, and 2 pi into your original function. This is again where you're going to need to know your unit circle values so that you can evaluate this properly. Pause your video, plug those into your original, and see if you get the same answers as I do. So I ended up getting -1, 3, -1, -3 halves, -3 halves, and 1, all just using my unit circle values and plugging those into the original. Okay? So now that I have those 6 values, I can then decide who my absolute maximum and who my absolute minimums are. It looks like I have an absolute maximum of 3. That happens when x equals pi over 2. And it actually looks like I have 2 absolute minimums because they're at the same lowest point of -3 halves. Those happen at x equals 7 pi over 6 and 11 pi over 6. So that's where I have my absolute maximums and minimums. Hopefully you got the same answer as me. That was a really good question. It had some trig derivatives with some chain rule. It had some trig identities. It had lots of unit circle values. That's a really good one.